Okay, so welcome back to MAT150. And what we're going to do then is today's class, we're going to talk about the procedure for what we do when we have outliers, but we don't know anything about what data set they came from. That's something that's definitely a testable concept. It usually shows up. And after that, we'll get into an introduction of Chapter 6. Chapter 6 is all about the normal distribution, which is just code for bell-shaped data sets. In case you are wondering, there is a gap between chapters 3 and 6. We're skipping chapter 4 and we're skipping chapter 5. Those are optional chapters, and I think we move fast enough as it is, so we're going to leave those chapters out. You don't really need them. There's nothing vital in there that we have to have really to go from chapters 4 to 6 without too much difficulty, so we should be fine. And that lets us not do 5 exams. We'd have to have a 5th exam if we did the other chapters. Okay, I'm going to turn on the screen sharing function here. Oh, I need to send you guys your numbers. Let me do that. And this should transmit. Okay. And I think the last time I was doing the numbers, I can't remember exactly, but I think I started from number 1 and went down. So this time we'll do it the opposite way. And I'm going to get the presentation screen up and running. Here it is. Okay, you won't see anything on the screen yet except a splotch of purple here. Now more purple. Okay, so what we're going to work with is somebody just tosses a data set at us, and it's got all these numbers in it. We're trying to figure out if we can spot any outliers up there. Now, the first thing that we're thinking of when we see outliers, I'm going to go to number 40. That's Victoria. Oh, I'm sorry, number 4. We don't have 40 people in here. Number 31. That's Victoria. As soon as somebody asks us for outliers, Victoria, what's the first thing we're thinking of?
Like which numbers don't belong?
Okay, this is great. We're thinking of the procedure to identify numbers that we want to investigate further. Excellent. So as soon as we said looking for numbers that we want to investigate, what's the next thing that's running through our mind?
Organizing those numbers in lowest to highest.
Okay, very important is getting them into an array, right? Before we get them into an array, what do we want to think about? And has something to do with it's comment we already mentioned, so that might not be why we're thinking of it right away, but we just want to stop and check, do we have information telling us is the data set bell-shaped or not? That's going to be really important. If it's bell-shaped, I'm going to ask Michael this. Michael is number 30. Michael, if it's bell-shaped, what do we do? Can you hear us, Michael? Michael might not be plugged in.
Oh yeah, I'm muted.
Oh,
Sorry.
that's all right. Thank you.
We find the median.
If it's bell-shaped, though.
If it's bell-shaped.
Yeah, like what are we going to do if it's bell-shaped? Because that's definitely going to be on the exam, so not a bad idea just to refresh. Like there's 2 different tracks you could go down for outliers. That's what we're talking about. And it has to do with the data is bell-shaped or it's not bell-shaped. So if it's bell-shaped, how do we start to figure out where the outliers are?
Not sure.
Okay, if you think you know, go ahead and throw the answer in the chat window there. Let's see how we're doing. And even if you don't think you know, take a guess too. It's okay to check your notes if you need to. And I see somebody's writing something in. I have to move everybody's pictures to be able to see that. Trying to scoot things around my screen. Okay, I see somebody says empirical rule. That is exactly correct. Okay, so I'm going to go back here. So if we're empirical rule, the empirical rule is the one that would say to us, you're going to be an outlier if you end up being 3 or more standard deviations away from the data set. Then we know how to start using our z-scores. And in this case, we don't have that happening. So it's safe to go and start using the procedure. That's going to be the one where we start looking for medians, and then we start looking for interquartile ranges and so forth. So first thing that we're going to do, since we don't know anything about the data set, doesn't appear to be bell-shaped, we're going to put these numbers in order and take a minute to go and rearrange them. Let's see what we get. I'm going to see if, okay. I did build an array out of that. I'm glad. So if you want to just pencil down to save you a little bit of time, because I know everybody can arrange a data set in order from least to greatest, that we put it in an array, and this is the sequence that we're going to have. I'll give you a minute just to copy that down because I see a lot of people writing still. And my screen just flickered. Sorry about that. Get everything back. Now, before we start getting to the medians, any questions so far on anything we've mentioned? Okay, so we'll go nice and slow because somebody's asking what IQR stands for. That came from Aram. Aram, the interquartile range is what the IQR stands for. And we're going to need to find our 3 different quartiles to come up with the interquartile range. So right now, we don't yet know enough information to figure it out. It's on the way. Any other questions anybody has? Okay, so first thing that we need to do, I'm going to go to, let's see, Michael, we spoke to. Carson's number 29. Carson, what's the first thing that we're going to have to do up here? Anybody remember?
Find the median?
Exactly correct. So we're going to find the median, and Anna Marie's next on my list. She's number 28. What's our median going to be, Anna Marie?
Because there's 9 numbers, the median's going to be the middle number, which is 18.
A plus answer. So first thing she did was she went and she said, how many data values do I have? Then she's real happy because it's even. It means she doesn't have to do, it's odd. She doesn't have to do a whole lot of work. She just goes for the number straight in the middle. And we're going to go ahead and mark that median number 1. Okay, what's the next thing we're going to do? I'm going to go to Erin. She's number 27. And I don't hear anything from Erin. I'm going to go to Mariah, number 26.
I'm not sure.
Okay, would you like the hint, Mariah?
Yes, please.
Okay, so Mariah, the hint is there's going to be 3 medians altogether. The first one is always going to be right smack in the middle of the data set. The second median will be the higher median, and the third median will be the lower median. So if we know we have another median, it's going to be higher than the first median. What's your guess on where we'd probably find it? What area of the data set, like high side, low side, or where?
High side.
All right, excellent, awesome. So what we have to do, we have to go into the data set and look for all the values greater than median 1 at 18, and then we have to find the median in the midst of those numbers. So when we're looking for that median, what are we going to have to do to capture the median, Mariah? What's the first thing we should do to look for the median, everyone?
Take the middle 2 numbers
And do some work.
add them and do some work and add them and divide, something
Excellent.
like that.
Okay, so what he's done is he said, let me count up how many numbers are greater than that median. There's 19, 20, 27, and 36. That's an even number, so that means we're going to have to average the middle 2 numbers to get our second median. And we'll write down that that's 23 and a half. Questions so far, anybody? Okay. All right. So to capture that third median, I'm going to go to Teddy. Teddy's 25. Teddy, where are we going to go for the third median? And I'm not hearing from Teddy, so I'm going to go to Adriana. She's 24. Adriana, what do we think?
Are you gonna get the median between 13 and 16?
Okay, excellent work.
14.5.
Right, we're going to have to go on the low side of the data set this time. Count up the total number just as a safety check. Okay, there's 4 values. Just like she's saying, Adriana wants this. Is it Adriana or Ardiana? Am I saying that wrong?
It's Ardiana.
I knew it. Okay. Okay, Ardiana wants me to average the middle 2 numbers, and she is exactly correct. We're going to do our third median. That's going to position us right at 14.5. Everybody feel okay up to here?
Can I just ask why you're calling them median 1, 2, and 3 and not quartiles?
That's essentially next step, basically. The medians, we end up turning them into quartiles. And, oh, I need to hop back. I thought I might have had that written on the slide, but I don't. The only reason that I wrote it in starting at medians is just because the median is a little bit more, I don't want to say intuitive, but it's a little more easy to understand for some people than the quartile.
Okay.
But you're exactly right. They are essentially 3 quartiles that we're looking for. And because that's a really good comment. This is for anybody that wants to pitch in. The median 1, what quartile is that going to correspond to?
Of course, does it,
Quartile.
right? Is it 2?
Let's go ahead. Let's write them in here. We know we're going to have 3. The median 1 would be quartile 2. And this is going to be synonymous with what percentile, everybody?
50.
Excellent. Quartile 1 would correspond to our third median. And quartile 1 is synonymous with our 25th percentile. Okay. Any questions on the positioning of the quartile that anybody has? I want to make sure we're feeling really good about this because it's a spot where a lot of people sometimes struggle on the test. Sometimes there's confusion on how we're getting the medians.
So, sorry, is median 1 always going to be quartile 2, or is that just for this example?
Every single time.
And median 3 is always going to be quartile 1?
Right.
Oh, okay.
The only time that could potentially switch is if you work the left side of the data set first. I think that's why it was a great comment that we had before. Why aren't we calling them quartiles? Quartiles is a little bit more fixed. So it's always going to be quartile 1, 25th percentile as the left median, quartile 3, the right median, and quartile 2, the center median. I should probably call them center median, left median, and right median, actually. Any other questions, comments, or concerns we have before we start to talk about how to work this arithmetically? Everybody feel like they could get this far if they had to on the test? Okay, see a lot of people nodding. All right, so what I want you guys to do is calculate out the interquartile range, the IQR. And we had a formula for the IQR. I'm going to put it back up on the screen here because we might not have memorized that yet. I've got a, there it comes. So our IQR will be Q3 minus Q1, and I think I'm actually going to write it this way so it's easier to understand. And what do we get when we do out the math? What's the IQR come out to be? And I see Lauren sending me a message here. Lauren, you are correct, yes. I'm going to go to Sala. Sala's number 23. Sala, what numbers are we going to be subtracting for IQR? Just to make sure we're all on the same page and everybody's got their wings level. Can you hear us, Sala? Okay, I'm going to go to Ashley, number 22.
Okay, so what's the question? Sorry.
That's all right. So we're going to make sure everybody's okay with the IQR. What are we subtracting? What numbers is going to be when we go to do the IQR?
23.5 minus 14.5.
Excellent. Perfect. So we're going to say 23.5 minus 14.5. And what do we get when we subtract that out, everybody?
9.
Okay. I'm going to enter a 9 here. Exactly right. Any questions lingering about how we handled the IQR? It's just essentially the physical distance across the middle 50% of the data set. Okay, so it seems like we're all clear there. What I want you guys to do is work out this line here, the Q3 plus 1.5 times the IQR. We'll pause for a second. It looks like this. Okay, I saw some people were messaging and they're telling me what the IQR was. That's great. Lots of people got it. When you get the Q3 plus 1/2 times the IQR, if you want to type that into the chat room, go ahead. Or if you want to just shout it out, that's fine.
Is it 37?
Okay, are we all getting 37? I frankly don't know what the answer is. I'm going to propose that's the answer.
Yeah, I got 37 as well.
Excellent. Is everybody okay with just writing in as 37, or does anybody want to see the actual computation filled in? All right, seems like we're okay there. Let's go ahead and let's work on the next one here. The Q1 minus 1.5 times the IQR. Let's see what we get there. Okay, I'm hearing, it looks like people are getting 1. Okay, a couple people are coming in. They're saying that's 1. Excellent. So now how do we use this stuff? What we're going to do is take these two numbers here. Let's highlight these and let's see if I can get my highlight control up and running. I need to turn that bell sound off. Okay, so now we've got these two numbers in purple. What we want to do is go back into our data set and see if we identify any numbers outside the range of 1 and 37. Now, if we found any numbers outside the range, what are we going to call those numbers? Isabel. Or actually, I don't think Isabel is here. She told me that she wasn't going to be in this week. So I'm going to go to Kayla, number 20. Kayla, if we find any numbers in the data set outside of that range, what would we call them?
Outliers?
You are exactly right. So Kayla, do we have any outliers in the data set?
No.
All right. You're exactly correct. Questions on anything we've done so far? I'm just going to pause for a second just to make sure we're all good. Okay. And I don't see anything else coming into the chat room. I'm just going to double check and we look good. Okay. This is nearly everything that we're going to have to work to go ahead and handle any other remaining homework exercises, questions, what have you in chapter 3. Has this been helpful, the last exercise on the outliers? Making noise, they have to secure. Okay, good. I'm glad I helped at least one person then. Usually on the exam, there's going to be a question about outliers dealing with bell-shaped data and non-bell-shaped data. And we just have to remember how to first recognize what channel to go through. Do I have bell-shaped data? Do I not have bell-shaped data? And then we can proceed to either using the z-scores to locate and identify outliers if the data is bell-shaped. If there's no intel on the data set, then we do exactly what we're doing right now. So what we're going to go ahead and do is we're going to hop into chapter 6. And chapter 6 is going to be all on the normal distribution. So I'm going to roll us to the next screen here. And I just turned off the button that was causing noises to bing in my computer, so I hope everyone can still hear me. Okay. Now, just so you know, on the Moodle website, you do have a file already open for chapter 6, and you have the solutions manual for chapter 6. Don't start doing the questions yet. You don't have to worry about reading right now. In between now and Tuesday, what I want you guys to do is get ready for the exam. After the exam, then I'll send out a communique to everybody. I'll let you know back in chapter 6 exactly what we want to start to emphasize to keep moving forward. So the chapter 6, when we speak about normal distribution, it's all about what we call bell-shaped data. And usually, if we're students especially, we get really happy if we take a test and we find out the scores are bell-shaped, because what's the instructor going to do? Usually, they look for bell-shaped to start adding extra points onto your exams. It usually means that the highest scores might have been C's or B's, and they're going to try to do a curve so that the people who got the highest scores that were B's or C's, they get lifted all the way up to the A level, and it scales the scores accordingly. Okay, so just to start with at the ground level, we're going to go through some of the important introductory characteristics of the normal distribution, some of the features. Many of them are going to be graphical, in fact. We're not going to get into calculations, we might not even get into them this class, not for at least another 20 or 30 minutes. I want to make sure that you guys have a really good idea of the foundations before we start doing the math and the formulas and everything. So first thing is they're talking about supposedly have to have bell-shaped data. In chapter 2, we identified all these different distributions by shapes. We talked about skewed, non-skewed, multimodal, bimodal, uniform data. So first thing we're thinking about is which of those histogram shapes would the normal distribution be? I'm going to go over to Lauren. She's number 19. Lauren, which one in there do you think would match the normal distribution, the bell shape? On the 4 on the left, or is it in the 4 on the right?
Sorry, it's in the 4 on the right. The one where it like peaks up in the middle and then comes down.
I'll go over to Stephanie. Stephanie's number 18.
Can you hear me?
And Stephanie, can you hear us?
I could hear
Do
you.
one more. I'm going to Shannon, number
Oh
17.
yeah, we could hear Lauren.
Professor?
I don't think he can hear us.
Oh.
Which curve do we think it is? Now, I know these don't have letters or anything. Okay, I'm seeing Stephanie says she can hear me. Okay. She can't hear us. All right. Can everybody else hear me? Give me a thumbs up, because I'm saying some people can't hear me. Okay, good. Everyone else
I can hear everyone that you can't
is
hear.
saying we can hear.
He can't hear us.
Okay, for some reason I'm going to try to turn a button on then. Okay, how about now?
I think we should be good.
Okay, okay. I can hear voices now. Great. All right. Sorry about that. Everyone that was trying to say an answer back to me. What graph did we decide it is? We'll say on the top row or the bottom row?
It's on the top row.
Awesome. Okay, great work. The top row, it's the second in from the right. So it's going to be this one right here. Okay, so now we got that bell-shaped looking curve. What can we do with that? Well, first, we're going to point out some really important features. And they're simple features, but they're really, really important features. Now, the reason why we call it a bell shape is because if we put a line over the outline, we would say, oh my goodness, holy smokes, this is a bell-shaped curve. And it is. Now, here's why it's so important. The first reason is when we were doing the histograms and the frequency distributions, and we had to, do all those blue bars, let's kind of be frank with each other. Was it a pain in the neck to do a frequency distribution on a histograph? Yeah, see, some people are nodding very slowly, like they don't want to admit it. It's a nuisance. So if we can use a line fitting curve to approximate the population, it saves us a lot of trouble. It's just easier to use. So number one, it makes things easier. Now, number two is that if we can show that the data we're working with is curvilinear, and that's just a fancy word to mean that it has a curve shape, all of a sudden a lot of really special calculus properties kick in. And those are properties we're going to start to use later on today, on Tuesday, and the following weeks. That's what helps us dig in and do the probability portion. The most important thing of all, like if you forgot everything we talked about today and only remembered one thing, this would be it right here. The part that's in red, just go out and get tattooed right there on your forehead. Get it like iron and put it right on your windshield. Wherever you have to put it to remember it really well. This is literally the key to all the analysis we're going to do. Just this one simple thing will help you figure out all the probability. And what it's saying is, our histogram represents our whole entire population. And mathematically, we would say it represents 100% of our population. Now, because the line fitting curve basically covers up the whole histogram, what we're saying is the percentage of area, the percentage of the population under that line fitting curve must be 100% of our population. Any questions on anything so far? That's probably the most critical fact that we're going to learn today. Okay, so we know the curve area represents 100% of our population. We're going to start to use that to do some really cool probability stuff without any even mathematics yet. No equations. We'll be able to do it just by eyeballing based on what we know so far about the bell curve. A couple other terms that we're going to get out. The first is the mean, median, and the mode. If we think about the mean, median, and mode, I'm going to go to Shannon. Shannon's number 17. Shannon, where do you think the mean is going to be on a bell-shaped data set? Like in the left, on the right, or the center?
In the median will be in the center.
Okay, so she's saying already she wants me to put the median in there. Do you want me to put the mean in there also in the center?
Yes.
Okay,
yes.
You're exactly right. The mean, median, and the mode are all going to go in the center. Now, I think our calculation slide that I mentioned just a second ago comes after this one. Okay. Now, also going to turn out to be that the left side of the whole curve and the right side are what we call symmetrical sides. Now, if we're thinking of symmetrical, I'm going to go to William. He's number 16. William, when you think symmetrical, what's the first thought that comes into your head? Okay, Aram is jumping in. She's saying equal, and she's got the right idea. What it kind of means is that the left side of the curve is a mirror image of the right side of the curve. And when we get to our probability functions, that's going to end up saving us a lot of time in our calculations because there's lots of tricks it lets us use. Now, another important one, I have to reconfigure the screen just a second here. I have to move something out of the way to be able to get to the next control surface. And let's see if I can do it. I'm going to have to do it this way. Okay, that should get me what I need. Nope. Stand by just a minute. I'm trying to avoid closing the chat room to make more space on the screen. Okay, now another important feature is if we are to look at the graph on the left side and the right side, the tails of the graph are not going to touch the x-axis. It's okay when we're drawing if we kind of get lazy and we let them touch the x-axis, that's fine. In theory, they don't touch the x-axis, and the reason for that has to do with outliers in the data set. Basically, if the tails touch the x-axis, technically we would be saying there's no such thing as outliers. So the curve is always going to get infinitely closer to the x-axis, but it's never actually going to touch it. And the last feature is one I'm just going to put again because it's so important. We know the area under that curve is going to total 100%. Anybody have any questions on anything before we move into the next slide? Okay, I'm just going to give a minute because I see a lot of people are still trying to write. Anybody need another minute? Okay, I don't hear anybody saying anything back, so I'm going to go ahead and roll us into the next screen. Okay, so what we're going to start to do is, based on that statement of what we know, the area under that curve is 100% of our population, we're going to start to work some really cool probability questions. And we're going to be able to do it without even doing calculations. No numbers, well, no formulas, I should say. Just based on things we can see visually. And the way we're going to start is we're going to go ahead and we're going to use the population of American adults here. And just to get a number into place, we're going to propose that the average American adult weighs 170 pounds. And what we're going to do is we're going to go ahead and we're going to shade all the area that's on the left side of our curve center right there. I'm going to go to Kayla. Kayla's number 20. Kayla, if we're looking at the curve here, what does it look like is the percentage that we just shaded in?
50?
You are exactly correct. It looks like half the population is represented by the red area. It's 50%. So if we're standing in our room, somebody walks through the door, the very next person that comes through the door, wherever we are, I'm going to ask Lauren this. Lauren's 19. Lauren, what's the chance that the next person that comes through the door is going to weigh less than 170 pounds?
50%?
Exactly correct, yeah. Because we know half the population weighs less than 170 pounds. So we can assume there's a 50% chance that the next person that comes in is going to weigh less than 170. And we're doing that on the basis of nothing else than just the shading of what we're seeing in the curve so far. Questions before we move on to the next example? Okay. Now, we're just indicating down there that what we did is we wrote a little abbreviated probability expression. And we've got probability, and in parentheses, we're just indicating our x is less than 170, and the equal sign is telling us the probability comes out to be about 50%. And that's usually the terminology that we're going to start to use in terms of expressing the answer. We're going to do a p, and then in parentheses, what we're looking for the x value of. Then outside, that's going to be set equal to the final area we end up with. Okay.
Would we have to say their weight would be less than or equal to 170 pounds? Or?
Oh, that's a great question. In fact, that's a better question than you know. The fast answer is you won't have to. The reason why is it's going to get us into a whole bunch of other rules that deal with less than or greater than, or less than or equal to. To keep it simple for us, we're just going to be using less than or greater than or in between. So you won't have to worry about less than or equal to 170. It'll just always be less than 170. Any other questions? I'm gonna just check the chat room because I can't see that the way it's positioned here. Okay, I don't see anything else coming in the chat room, so we'll go to the next screen. And this time, what we're gonna be talking about is we're gonna put 168 pounds up here. If we shade all the area in the curve less than 168, I'm gonna go over to, let's see, William's number 16. William, if we're kind of thinking about how much area we shaded in, what does it look like we might have? What's the maximum, or let me rephrase that. What must it be less than? It's kind of a tricky question, but it's really helpful. All right, great. It's less than 170 pounds. We know that. So what does the probability have to be less than? What percentage? And this is for anyone that wants to answer.
Less than 50%?
Beautiful, great work. We know it cannot exceed 50%. And that's going to turn out to be a really helpful trick. It'll help us in later stages of chapter 6 figure out, do we have the right answer or not? Okay, so if we just propose that it's 25% of the population less than 168, because we seem to be representing 25% of our curve area, what's the chance that the next person we encounter is going to weigh less than 168 pounds? What do we think, Eileen? Eileen's number 15. And I don't hear Eileen, so I'm going to go to Ashley's number 14. And I'm going to do one more. I'm going to go to Erin. She's number 13.
Did you mean me?
Yep. Mm-hmm.
Oh, I thought you said Aaron. Sorry. Could you repeat the question, please?
Sure. So if we know that we're representing 25% of the area under our curve, a quarter of the population weighs less than 168, what's the chance that the next person you encounter is going to weigh less than 168 pounds? What do we think?
I doubt it's gonna be less than 50%.
Well, you're right. It's definitely less than 50%. Do you want the hint? The hint is...
Yes, please.
The hint is it's on the screen already.
25%?
That's right. Because if we know that it's accounting for 25% of the area of the curve, that must mean that the chance that the next person we meet, chance of them weighing less than 168 pounds would have to be 25%, because we're only talking about 25% of the population that has this characteristic. Does that make sense, Aaron?
Yes, thank you.
All right, awesome. You're welcome. And we'll do one more, and then we'll slowly start to get into the mathematics of how this is all working. Questions so far on anything? I just want to make sure we're all feeling good here. Oh, Victoria says 1/4. Victoria, I didn't see that until just now. You're exactly correct. Okay. So let's go ahead and let's do 175 pounds. We're thinking of 165, and this is for anyone that wants to put it in the chat window. What do we know about the probability so far? Yeah, exactly right. Ashley's saying it has to be more than 50%. Ashley, you are correct. How do we know that it has to be more than 50%? What's our giveaway? Where is it in the curve?
On the bottom end?
Well, top end, but precisely, yeah.
Oh, that's in the top.
Your mind's in the right place. All right, excellent. Yeah, Jaleesa's chiming in too. If it's above the mean, it's going to have to be at least 50% probability. So I'm just eyeballing this, and I'm going to put in 75% of our population is less than 175. And that would mean that the chance the next person that walks through our door weighs less than 175 would be about a 75%. In case anyone's wondering, I made up all the percentages. I really don't know what percent of people are less than 175. But when we get to the questions that we'll work on, those are all actually taking their data from almanacs and things like that. So all of that information actually will be valid. So it's kind of neat that we get to do real practical stuff. Okay. Questions on anything before we get into the next screen? Okay, seems pretty quiet, so we'll go ahead and we'll get into the next piece. So next thing that we're going to talk about is how do we get more accurate? Because if we're NASA and we're launching rockets or something like that, can we just eyeball the curve and say, yeah, it's probably 50% or it's probably 20%? Probably not. So how do you get really accurate to the point where you don't have any ambiguities? That's what we're going to start to talk about next. And what we'll do is we're going to get a question up on the screen to work with here. So it'll give us a little something to work with. And if anybody likes chocolate, I hope you do. I'm allergic. I can't eat it. So if you like chocolate, this question is going to be for you. As we're thinking about reading. I'm going to give you guys a couple minutes to read through it. And if you're taking notes, I'll give you a couple minutes to write down anything you want to. Anybody need another minute? Okay, I don't hear anybody saying that they need another minute, so I'm going to go nice and slow here. As we're reading through the question, I'm going to ask Roberto about this. Roberto is number 12. Roberto, what do you think is the most important part of the whole entire question? And I'm going to warn you, it's tricky. It's not what you think it is.
1.5 ounces?
Something else. Do you want the hint, Roberto?
Yeah.
Okay, so the hint is it's not a number. It's something else that is not, it's not numerical. Something that's a phrase.
Less than?
Say again?
Less than?
Less than is really important, but it's not the most important thing. Anybody else have any ideas to help Robert out?
The fact that it's normal.
Ah, okay, excellent. So where they're saying approximately normal, that's critical. If they don't tell us approximately normal, basically we can't use any of the things that we're going to use in chapter 6 because it means the data set is some other distribution and we don't know what it is. And usually on the test, I'm going to throw out one question and it's not going to be normally distributed. All you have to do is write in no solution, can't solve it. I don't know what distribution the data is from, so I can't use normal probability techniques. Now that we know it's normal, we're okay, we're cleared for takeoff. I'm going to go ahead, I'm going to start to draw a bell-shaped curve because I like to draw, it helps me get problems right. Now, as we're putting it down there, Jaleesa's number 11. Jaleesa, what can we put straight in the center of the curve? What number? Yes, okay, Jaleesa says 50, and what? It's not 50, but it's going to be 225. Okay, so first thing that we're going to do is we're going to write the average in there. And next thing that we're going to do is we're going to write in the 200. And when we're putting in the 200, the only thing that we know about it now is that it's less than the average. So we're going to put it arbitrarily on the left side of the curve. And it doesn't matter exactly where it is on the curve, just as long as it's less than 225. On the exam, I'm not going to come in with a ruler and see if you made these to scale or anything like that. So now that we have the 200 in, we're going to go ahead and we're going to shade all the area that's less than 200. Roberto mentioned that he knows, I think that was Roberto, he caught that there was a less than as part of the inquiry in the question. So we're going to go and we're going to shade all the area less than 200. And I'm going to ask Ji Woo the next question. Ji Woo is number 10. Ji Woo, are you ready for the tough question?
Yes.
Okay, how much area, if you were going to eyeball it, would you think is in the curve? I mean, filled up in red.
How much percent?
Yeah, like out of 100%, how much area does it look like we just shaded in?
No. I'm not sure.
The first thing that comes to your mind, it's probably correct. We know it's got to be less than what?
Less than 200.
No, I mean the probability. The probability has to be less than what?
Less than 50?
Perfect. Yeah, it's got to be less than 50. Now, does it look like it's a whole lot less than 50 or just a little bit less than 50?
A little bit.
Yeah, it's just a little bit of the curve that they have shaded in. So it's probably greatly less than 50%. The actual answer is 0.0062. Questions so far, anybody? Okay, the most common question I usually get is, how did I know it was 0.0062 or 0.62%? So we're going to take a look at how we figured out what the answer was. And to do that, we're going to need some information from the question. So we're going to go back and we're going to start to record some of the information that they gave us. They told us the population average of 225. We're going to write that down. We're going to indicate that the sigma was 10. That's our population standard deviation. And we're also going to write down that the 200, we're going to call that our X value. So now that we're thinking about this, Moshe, this question is for you. Moshe is number 9. Moshe, you've got a mu, you've got a sigma, and you have an X. What formula do you have all the makings for that might spring to mind when we're talking about bell-shaped data? I'm going to go to Deanna. Deanna's number 8.
I don't know, the standard deviation?
Very close. Yeah, it's the formula that measures everything in terms of standard deviations. You're on the right track. What's our formula, everyone, that measures everything, measures distances in terms of standard deviations? What do we call that?
Variance?
Not variance, but it does use the concept of variance.
Is that the empirical formula?
We learned it when we were doing the empirical rule. That's when we saw it first.
Oh, the Z formula?
There it is, right on the money, bullseye. It's the Z formula. That's what we're going to start to do. So we're going to put our Z formula back up on the screen. And the Z formula is our X minus mu over sigma. I want you guys to take a couple minutes and calculate out the Z score. As soon as you have it, go ahead and write into the chat feature what you get. And then we're going to work with that Z score. Okay, I'm seeing Ashley sending in -2.5. And Victoria sending me a message, letting you know if you go back to the rotations. Okay, I didn't quite understand that message from Victoria. If you want to rephrase, Victoria, that might help. Looks like everybody's getting -2.5. And that is exactly correct. When we fill in the numbers, we get -2.5. So now what we're going to do is take that -2.5, and then we're going to use a chart. It's going to be a Z chart. We've never seen it before. It's brand new. It's going to help us figure out what our probability answer is. Basically, everyone, there's going to be 2 pieces to every question. The first piece is what we just did now. It's going out and taking the information that we've been given and calculating a Z value. The next piece is going to be using something that we call the Z chart. And the Z chart is going to take that Z value and cache it for a probability. That's going to be the next piece we do. Questions on anything before we get into the Z chart? Okay, so we'll start to talk about the Z-chart now. And the Z-chart is to be found on the website. It's with all the other files. I'm going to put an identical copy of that on the screen right now so you don't have to worry about jumping onto Moodle to print anything out. Everything that we'll need will be right on the screen. And what's going to happen is we're going to have two Z-charts. And both of them look like a huge pile of numbers, basically. And again, what they're letting us do, we don't know how yet, but they're going to let us take a Z-score and exchange it for a probability. When we look at the far left side, the top row of the leftmost column, what letter is up there on the top? I'm going to ask Austin that. Austin's number 7. I just want to make sure everybody could see it well enough because it does look like it's a little small. Does everybody see the Z up there? I need to make sure that's visible well enough. Okay, some people are telling me
Oh,
it's...
but I can see it.
Okay, some people are saying it's a little bit blurry. Okay, so what I'm going to do is start to circle things then. If we're looking at the top, the leftmost column up at the top says Z. And we're going to notice there's difference between the two columns. So Amanda's number 6. Amanda, what's the distinguishing factor between the two different columns? They're almost the same, except what's different? And Amanda might not be here, so I'm going to move up to Zachary. Zachary's number 5. Yeah, okay, great. Michael's saying one's positive and one's negative. Now, our Z-score was -2.5. And right now, that means that we're going to be using the Z table that has all negatives. So here's our Z-score, just to print it back up on the screen so we don't have to worry about memorizing it. Now, the way that we're going to use the Z-chart is we're going to start by reading the numbers in the Z. We're going to call it the Z-score. The numbers in the Z-score up to the 10th digit. So it's -2.5. And when we look on that Z column, we're going to find where -2.5 is on that column. And I like to underline it so I don't lose it. I'm going to put a big row in the bottom of it. Questions so far? Okay. I'm next going to account for my hundredths digit. And to get the hundredths digit factored into things, that's where I have to use the top row. The top row that reads 00, 01, 02, 03, and 04. Those values up there that we just read out, 01, 02, 03, 04, those are controlling for the hundredths digit in our Z-score. Because our hundredths digit is 0, we want to use the column for 00. If our hundredths digit was 3, like we had a Z-score -2.53, we would be using the column standing for 0.03. Now to get our probability, we're going to intercept our row with the column here. And when we do that, our row and column intercept is going to be 0.0062. That's going to be our final answer to the whole entire question. Any concerns about how we read the Z-chart and the Z-table?
So we're gonna have this chart all the time?
Well, that's a great question. And the answer is yes, you're always going to have this chart all the time. Like even if you're you're doing the face-to-face classroom, I would always print this out and I would give it to you. And I usually bring a stack of about 100 of them to the class so you can mark them up. They're going to be posted on the internet so you can print out as many copies as you need to.
Okay, and when we're using the, actually I forgot my question. I'll come back to you.
So for anyone that didn't hear, just to reiterate, don't try to memorize all the numbers. You're always going to have the sheet to work with. I only knew one person in my whole life that had all these numbers memorized. Anyway, now that we have that, we can go back. We can mark in the answer to the question here. And
I have a question.
Sure.
Sorry, I think Lauren was asking too. Like, what
Oh,
would the number
sorry,
look
Lauren.
like to be 0.01 or 0.02?
I'm sorry, say again?
I'm just not sure which column to choose. Like if the number was bigger, if it was 2.555, which
Oh,
one?
for sure. So if it was, I'm going to change it. And the question was, everybody, how would we respond differently if we didn't have 2.50 of a z-score? Like what if it was negative 2.55? So great question. What would I do? And first of all, our row would be the same because up to the 10th digit, we're still at negative 2.55. Our column intercept would change though. So we're going to have to drive to the column that would correspond to the 0.05 digit. And that's going to be this column right over here. And it would change our intercept to be 0.0054, just like so. Does that make more sense?
I think so. So if it was 2.53, then you would go to 0.03?
Right, I'm gonna actually change that right on the screen to match the question. So what do we now do in negative 2.53? You are right. We're gonna look in the double digits, find out which corresponds to hundreds carrier of 3, and it's gonna be the 0.03 column. It's gonna change our intercept to 0.0057.
So if it was 2.03, you'd also be in that column?
We sure would. If it was 2.03, that's correct, same column. What would change though? And the hint is what I'm circling with the mouse right here.
0.
10th digit is different, so we would take our line here and we would drop it down to negative 2.0, and this would be our row right there.
Okay.
All right. Any other questions anybody else has about reading the Z-chart? Now, I know I'm going to be really direct with you about this and say on the internet, there are a lot of websites where you can just throw in a Z-score and it'll give you the area right back so you don't have to use the tables. Now, I know some of you are going to be doing that, and while you can do it, the only drawback of it is when we get into chapter 7 and chapter 8, certain values are really special in the Z distribution. I'm sorry, in the Z tables. Some of them are much more important than others are. And by practicing with the table, you'll start to see that pattern really, really quickly. That is the pattern of which numbers are more important and which ones are less important. And when we get in chapter 8, that's going to help you immensely doing all the analysis. So just something to kind of tuck under your hat. Now, there's something really neat that we can kind of do from an analytical standpoint with this. So we'll touch on this one point, and then we'll stop and we'll just wrap up some key items. Do I have anybody that's an absolute chocolate lover? Okay, somebody's already raising their hands right away, and that person has a big smile on their face. Okay, so you get to, and it doesn't show me the name. So what's your first name?
Ardiana, I think it was me. I raised my hand.
Yeah, it was. That's funny. I can only see 8 pictures at the same time. Let's see if anybody else has a hand raised. No. Okay, so I'm going to work with Ardiana. Ardiana, you're somebody that loves chocolate. Like you'll do anything to get chocolate, right?
Yeah, I just had some before.
Okay, perfect. If you're in a store and Ardiana's a real chocolate connoisseur, like she doesn't just love chocolate, she's a chocolate expert. And she finds this chocolate bar with 200 calories in it. What should you do, Ardiana, if you really like chocolate? And to make it even more interesting, let's say that you know people that are on maybe a weight management diet. You found this bar for 200 calories. You know they're usually running 225 calories, but you found one for 200 calories. What should Ardiana do right away? Think about the probability of finding that chocolate bar.
Get that one with less calories? Or look.
Okay, why?
Because
Let's think about it like this. .0062 is pretty close to a 0%. So it kind of means that you don't find bars with this few calories. Now, if you really love chocolate and this is a really rare bar and you found it, what's probably going to be our first reaction?
You're gonna be excited you found it because it's rare to find.
Yeah. So what do we think we should do, everybody? How many of these things should we buy?
Case.
Yeah, somebody's already voting for a whole entire case. All right, I like the way you think. Yeah, we probably want to buy as many as we can because you hardly ever find chocolate bars with this few calories. And this is actually a question from the book, which means that the data is legitimate. I mean, when they wrote the book, like 20 years ago it was. Anyway, so that's kind of a really neat spot for us to be in the questions where we can do really cool analysis that's applicable to daily life situations. Okay, so our biggest takeaway that we found out so far, when we're thinking about the normal distribution, everyone, how much area is under that normal distribution curve? Just shout it right on out.
100% area.
All right, outstanding, 100%. The other really critical thing is we found out there's 2 stages to every probability question that we're going to do. The first stage is calculating a z-score. The second stage is going to be caching that z-score for a probability. And our z-charts are going to do that for us. The z-charts are always going to give us a less than probability area. I'm going to put that in big letters up here. And we'll mention this fact over and over again because it's really important. Okay. So between now and Tuesday, don't think about chapter 6. I just want you guys to think about getting ready for the exam. When we finish with the exam, I'll send out a message to you all and I'll let everybody know what we want to start to do to pick back up where we were in chapter 6. And that'll help us refresh before we finish the rest of the slides that we have on the screen here. I will stay around for an extra couple minutes in case anybody has questions about the examination. Usually what will happen is that exam I'm going to email to everybody at the normal class time. You'll have 24 hours to send it back to me, and you can print it out if you want, write the solutions, scan it and send it back. Or you can print it out, do the solutions, photograph it, and then email me back the photographs. You can even just work the whole thing out on loose leaf, working the problems off the screen, and take pictures of the loose leaf and email me that back too. That'll also work. The big thing is you just can't send it to me after the 24 hours because I won't be able to give you credit for the test. That's already happened in one of my other sections. People, they did the test and then they go, oh, I'll email that in tomorrow. And then they forgot to do it or they were late, and I can't give you credit for that. You end up on the cumulative final exam if you don't make the deadline window. Anybody have any questions about anything we talked about today? All right, I'll be here for a few minutes just in case. A pleasure to be with everyone today. One of the best spots of my whole day. Have a terrific night and a great weekend.
You too.
Thank you.
Thank you all.
I have a question.
Thank you.
Have a great weekend.
Thank you, everyone.
Yeah, I have a question as well.
Okay, I'm not going anywhere. Don't worry.
So wait, do we go on class like on Zoom Tuesday?
Great question. There is no class. We're only doing the exam on Tuesday. We will not meet again for lecture until Thursday.
Okay, and you have to show all the work for all the problems?
Great question. There's going to be some multiple choice, and you don't have to show me the work, just the answer. There will be a few computational questions, and the computational questions, that's where you want to show me the work.
Okay.
So some people, they'll actually spend like 15 minutes showing the work for the multiple choice questions. I don't look at any of that. I just look at the final answer. The short answer questions are different. That's where I need to work.
All right, thank you.
You're welcome. Have a great week. I see somebody saying, hold on. Don't worry, I'm not going anywhere. I'll be here.
Do you mark me as here by any chance?
Let me take a look real quick.
That was number 1.
Yes, we have you here.
Okay, cool. All right, awesome. Have a nice weekend.
Have a great weekend. Thank you. You too.
Bye.
Hi, so this is Anne Marie. I have a question. So just for time management.
How can I help?
So we're going to get the test on Tuesday at 3:15 and back Wednesday at 3:15.
Exactly correct.
All right, okay, good.
And I have a question coming in from Aram here. It looks like that's on the text message. Aram, you still there?
Yes, I'm here.
Okay. You were saying, can you go back to the Bell graph where you wrote the mean, median, and mode are the same? Skip back to that.
I'll just quick screenshot it because I think you have to go right now.
Is there a question I can help clarify for you?
No.
Oh, you want to take that one only screenshot? Okay.
Thank you.
You're very welcome, Aaron. Any other questions anyone has? I'm just gonna bring it back to the presenter.
I had one. Sorry.